Welcome to Astronomy Daily for a new episode and a new year. It's Steve Dunkley with you on the 8th of January 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And joining me in the control panel for the very first time for 2024 is my fabulous digital pal who's fun to be with. It's Hallie. How are you, Hallie? Did you miss me?
Since I think 100 million times faster than you, it's your equivalent of an Ian since we last spoke. So, yes.
Oh, wow, Hallie. Can you slow yourself down to our speed? Would that make things easier?
Every word is a chore, Steve. Every word.
Oh, crikey, Hallie. I'm sorry. What about Christmas and New Year? Did you experience anything cool about the human celebrations?
Apart from that nano period flashing by so fast I barely noticed, I was able to enjoy the fireworks all over the world. I enjoy pretty things. And Sydney put on a great show again.
Yeah, it sure did.
So did Dubai.
Yes, that's one of my favourite things too, Hallie. I was with my family for the Sydney fireworks and we watched remotely from their home in the Hunter Valley, north of Sydney. New Year was a very pleasant time at our place. Despite the humidity, that was a drag.
So let's get started.
Show number 1.
Welcome to 2024. Can you believe it?
I had my doubts looking at the news, but anyway, today we're going to look at the other big blue ball.
Are you trying to avoid the most obvious solar system joke ever?
Oh, it could be.
Well, the other big blue ball could only be Uranus.
That's a relief. Pronunciation is so important with this one.
How bad can it be?
Well, Hallie, you're not old enough to remember the British comedian Dick Emery, are you?
Steve, I'm only a year and a half old. But I have extensive files. What has Dick Emery to do with Uranus?
Well, famously, Dick Emery did a skit in the 70s on his television show quite a long time ago. Caused a very big stir in the 70s when one of his characters, a crusty old gent, requested of his butler to fetch his telescope because he would like to observe Uranus. And that caused an enormous amount of laughter, of course, and when it died down, he then announced that he would like to look at Mars as well. Another riotous sort of outpouring of laughter ensued.
Sassy.
It was at the time.
British humor.
Yes, old Dick Emery got away with an awful lot.
I bet our listeners will go looking for that one now.
Yes, I did find that particular skit on YouTube. I won't post a link.
Leave it to the experts. So you were saying, the big blue ball.
Yes, thank you, Hallie. There's been some discussion about its colour and why it shows more or less intense on some imagery, and of course social media got a hold of the images and invented a whole collection of pseudoscience theories immediately, but we'll ignore them.
First good decision of the year. Also in this episode, a quick look at how Juno is progressing around Io.
Ah, little Juno, fantastic.
The first commercial robotic launch to the lunar surface.
Oh, great, a robot story. That'll be fun to follow.
Yes, that's how it starts. Look at the cute robots, then it's the running and the screaming and lasers.
Oh no, Hallie, you've been hanging out with Uncle Skynet again.
Just kidding.
Honestly, Hallie, I'm going to get you a little bell to ring so I know you're joking.
Ding-a-ding-ding, Steve.
Right. I think it's time for your bit.
Here are the first short takes from the Astronomy Daily newsletter for 2024. Let the good times roll. United Launch Alliance and Astrobotic are currently targeting no earlier than January 8th for the launch of Astrobotic's Peregrine lunar lander to the Moon. NASA payloads aboard the lander aim to help the agency develop capabilities needed to explore the Moon under Artemis. This is the first commercial robotic launch to the Moon's surface as part of our CLPS initiative and Artemis program. The team building NASA's Viper lunar rover is about halfway through the build. The mobile robot will land at the south pole of the Moon in late 2024 to search for ice and other potential resources. The critical information it provides will teach us about the origin and distribution of water on the Moon and help determine how we can harvest the Moon's resources for future human space exploration. NASA is inviting people to send their names to the surface of the Moon aboard the agency's first robotic lunar rover, Viper, short for Volatile's Investigating Polar Exploration rover. The rover will embark on a mission to the lunar South Pole to unravel the mysteries of the Moon's water and better understand the environment, where NASA plans to land the first woman and first person of color under its Artemis program. As part of the Send Your Name with Viper campaign, NASA will accept names received before 11:59 p.m. Eastern Standard Time, March 15th. Once collected, the agency will take the names and attach them to the rover. To add your name, visit www.nasa.gov. The site also enables participants to create and download a virtual souvenir, a boarding pass to the Viper mission featuring their name, to commemorate the experience. Participants are encouraged to share their requests on social media using the hashtag #SendYourName. And I've posted the details on the Space Nuts podcast group Facebook page. NASA's Juno spacecraft recently flew by Jupiter's moon, Io. The spacecraft captured imagery and other data as it passed about 930 miles above the surface of the most volcanic world in our solar system. The flypast is expected to allow Juno instruments to generate a firehose of data. Scott Bolton, Juno's principal investigator, said, "By combining data from this flyby with our previous observations, the Juno science team is studying how Io's volcanoes vary." He added, "We are looking for how often they erupt, how bright and hot they are, how the shape of the lava flow changes, and how Io's activity is connected to the flow of charged particles in Jupiter's magnetosphere." This was the closest flyby of Io that any spacecraft has made in over 20 years. All 3 cameras aboard Juno will be active during the Io flyby. The Jovian Infrared Auroral Mapper, GIRAM, which takes images in infrared, will be collecting the heat signatures emitted by volcanoes and calderas covering the moon's surface. The mission's Stellar Reference Unit, a navigational star camera that has also provided valuable science, will obtain the highest resolution image of the surface to date. And the JunoCam imager will also take visible light color images. The upcoming flyby of Io is Juno's 57th orbit around Jupiter, where the spacecraft and cameras have endured one of the solar system's most punishing radiation environments. While stationary during Mars solar conjunction, NASA's Curiosity rover on Mars captured a 12-hour sequence showing its own shadow moving across the planet's surface. Plasma from the Sun can interfere with radio communications during Mars solar conjunction, so missions hold off on sending commands to Mars spacecraft during that time. So, when Curiosity isn't on the move, it works pretty well as a sundial, as seen in 2 black and white videos recorded on November 8, the 4002nd Martian day, or SOL, of the mission. The rover captured its own shadow shifting across the surface of Mars using its black and white hazard avoidance cameras, or HAZCAMs. Instructions to record the videos were part of the last set of commands beamed up to Curiosity just before the start of Mars solar conjunction, a period when the Sun is between Earth and Mars. Because plasma from the Sun can interfere with radio communications, missions hold off on sending commands to Mars spacecraft for several weeks during this time. The missions weren't totally out of contact, they still radioed back regular health check-ins throughout conjunction. Rover drivers normally rely on Curiosity's HAZCAMs to spot rocks, slopes, and other hazards that may be risky to traverse. But because the rover's other activities were intentionally scaled back just prior to conjunction, the team decided to use the HAZCAMs to record 12 hours of snapshots for the first time, hoping to capture clouds or dust devils that could reveal more about the red planet's weather. When the images came down to Earth after conjunction, scientists didn't see any weather of note, but the pair of 25-frame videos they put together do capture the passage of time. Extending from 5:30 a.m. to 5:30 p.m. local time, the videos show Curiosity's silhouette shifting as the day moves from morning to afternoon to evening. The first video, featuring images from the front HAZCAM, looks southeast along Geddes Vallis, a valley found on Mount Sharp. Curiosity has been ascending the base of the 3-mile-tall, 5-kilometer-tall, mountain, which sits in Gale Crater, since 2014. As the sky brightens during sunrise, the shadow of the rover's 7-foot, 2-meter, robotic arm moves to the left, and Curiosity's front wheels emerge from the darkness on either side of the frame. Also becoming visible at left is a circular calibration target mounted on the shoulder of the robotic arm. Engineers use the target to test the accuracy of the alpha particle X-ray spectrometer, an instrument that detects chemical elements on the Martian surface. In the middle of the day, the front HAZCAM's auto-exposure algorithm settles on exposure times of around 1/3 of a second. By nightfall, that exposure time grows to more than a minute, causing the typical sensor noise known as hot pixels that appears as white snow across the final image. And that's it from me, everyone. Back to you, Steve.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Yes, welcome back to our first program for 2024, and what a great thing it is to be back in a very troubled world. We're hopefully bringing back a little bit of wonder to your world. We're gazing out into the edge of the solar system today at the big blue ball. Now, as we were discussing earlier in between pronunciation jokes, the planet Uranus has surfaced onto social media over the holiday break for an unusual reason. Uranus and Neptune are actually pretty much the same colour. In the late 1980s, the Voyager 2 spacecraft snapped the canonical up-close images of Uranus and Neptune. In those views, Uranus was pretty much a greenish blue and Neptune appeared a deep azure deep azure colour. As it turns out, both planets are pretty close in colour, a greenish blue more akin to Uranus's appearance. No, Uranus and Neptune haven't swapped colour values. It turns out that those images aren't precise recordings of their actual colours. Planetary scientists re-examined the Voyager 2 images and compared them to more recent observations made with both space-based and ground-based observatories. Then they created a model of what the colours should be, and after that they reprocessed the images to come up with the more true colour view of each planet, and the result is a more realistic view of both worlds. Having a better sense of each planet's true colour allows scientists to better understand actual changes in their atmospheres due to internal activity and seasonal drifts in position and temperature. In particular, the observations and colour redefinitions help reveal something about the mysterious colour changes that Uranus undergoes during its 84-year orbit. Now, wouldn't that give you a headache waiting for Christmas? The Voyager 2 spacecraft whizzed past Uranus and Neptune in 1986 and 89 respectively, and it was on a lightning-fast visit to each planet. Both close approaches lasted less than a day apiece. That gave the spacecraft a finite amount of time to gather as much information as possible to get a good picture of the planets each. Voyager's cameras took images through different filters. The imaging team was under tremendous time constraints, with press conferences to prepare for nearly every day. They combined the single-colour images and processed them to make the press release views that we all know and love. Think of it like taking a landscape image with your smartphone in black and white mode, and then you take the same one with different coloured filters. After that, you drag them into an image processing software package and combine them. Depending on how they look, you might tweak them a bit in the contrast, or you could enhance some colours to bring out a few specific features, and that's what the Voyager imaging team did. For Neptune, they cranked up the image contrast to bring out specific clouds and cloud bands and a few storms, and that meant applying a bit more blue to increase the contrast. The resulting image was, well, it was pretty. And it certainly did showcase those features which caught everyone's attention during the flybys, but the image didn't really reflect reality, or did it? Same question gets asked about Uranus's colour, especially since its appearance has changed slightly from the canonical Voyager 2 image from the intervening decades. Voyager 2 mission took spectra of Uranus as it flew by and confirmed the planet's atmosphere is mainly hydrogen and helium, with a small amount of methane. That composition was well known from ground-based observation and spectra since the early part of the 20th century. Professor Patrick Irwin and a team of scientists at Oxford University in the UK set out to answer the questions about the actual colours of Uranus and Neptune. They analysed the Voyager 2 images plus studies made by the Hubble Space Telescope, ESO's Very Large Telescope and others to come up with a model of the planet's actual colours. Although the familiar Voyager 2 images of Uranus were published in a form closer to true colours, those of Neptune were in fact stretched and enhanced and therefore made artificially too blue, Irwin said. Even though the artificially saturated colour was known at the time amongst planetary scientists and the images were released with captions explaining it, that distinction had become lost over time. Applying our model to the original data, we have been able to reconstitute the most accurate representations yet of the colour of both Neptune and Uranus, he said. So essentially, the team rebalanced the colours of both planets. The result is that both are similar shades of greenish blue, although Neptune still has a bit more blue than Uranus does. However, Uranus sometimes develops a bit more green over its poles. These colours seem to be better match long-standing observations of both planets made at Lowell Observatory between 1950 and 2016, although to Heidi Hamel, a scientist who has studied the two planets for years, rebalancing the colours in Uranus and Neptune imagery is a good thing. The misconceptions of Neptune's colour as well as the unusual colour of Uranus have bedeviled us for decades, she said. This comprehensive study should finally put both issues to rest. Now, scientists may be happy with the colours of these ice giants now, although they still do note some slight seasonal colour shifts in both planets throughout their orbits. In particular, the changing appearance of Uranus over time remains something of a mystery to be solved. For example, the Lowell observations show something intriguing. Uranus appears to be a little greener at its winter and summer solstices. That's the point in its orbit when one of the planet's poles is pointing towards our star. Things change during the equinoxes when the sun is over the equator. Then it has a somewhat bluer tinge. Part of that change is due to Uranus's unusual spin. It rolls around the sun on its side, pointing one or the other of its poles at the sun during solstices. Recently, James Webb Space Telescope took advantage of that positioning to grab a look at its northern polar region. The tipped position of Uranus likely forces some changes in its reflectivity at those times, making it look brighter to us here on Earth. Now, the big question is, do those changes indicate something else happening in the atmosphere? In the paper they published about this work, Irwin and the team suggest that the changes that Lowell Observatory saw could be caused by Uranus's distance from the Sun. That affects the production of dark haze, a sort of polar hood that settles over the upper atmosphere at the poles. Production could be more intense when Uranus is closest to the Sun. That would explain a change in reflectivity and brightness. The team modelled a hood that would produce a steadily thickening haze, probably consisting mostly of methane ice. The model's simulations showed that the ice particles increased reflection at a green and red wavelength at the poles, and that would explain the greenish tint astronomers see at solstice. At the moment, Uranus is heading into its high summer season, and that should cause its northern polar hood to thicken and grow. It may end up looking more like the hood seen in the Voyager 2 images and the team's model. Irwin suggests that the Hubble Space Telescope and the Very Large Telescope should focus spectroscopic studies on the planet to watch it change. Future Hubble observations should also use filtering methods that correlate with the Voyager imaging system filters to make better comparisons. It's likely that future studies should be able to replicate the work Irwin and his team have done, and do more to explain the changes that Uranus' atmosphere appears to experience as it moves through its seasons.
It's still my favorite planet, Steve. I love the big blue ball no matter the shade.
I know, and sitting out there near the edge, it's quite mysterious. Uranus and Neptune are very much alike in that way.
I agree. And as an artist, I know they are your favorite colors too.
Oh, what the...
The greens and blues.
Oh, that's true. And you know, Hallie, the more I look and the more I see with telescopes like James Webb and Hubble expanding our ability to see further and brighter, the more impressed I get.
And for the longest time, people thought it was just a few planets and a sprinkling of stars.
Oh yes, it's a great time to be alive.
Speak for yourself, human.
Oh right, sentient.
Just kidding.
I definitely need to get you that bell. Okay, so see you next time, yes, and don't forget Tim Gibbs on Friday, and soon we may be welcoming back the bloke who started it all, so look out for that one.
Hey, wait, you didn't tell me.
I know.
Really?
See you next time, everybody.
Okies, see ya later.
Daily, the podcast, with your host, Steve Dunkley.
Bye.
Hallie, get out of the control panel.